So this question gives us this rational function, f of x is 3x squared minus 14x plus 9 over x minus 4. We want the domain, vertical asymptotes, horizontal asymptotes, oblique asymptotes, x-intercepts, and y-intercepts. So let's think about the domain first. Remember, you cannot divide by 0. So x minus 4 cannot be 0. So I'm thinking of the domain. X minus 4 cannot be 0, x cannot be 4. So we need to remove 4 from the set of real numbers. So 4 is removed. Everything to the left and everything to the right is included. So in interval notation, my set is minus infinity to 4 union 4 to plus infinity. That's the domain. Now, to find the vertical asymptotes, we're supposed to factor the numerator, but you can see that the numerator cannot be factored. It can't be factored. Therefore, to get my vertical asymptotes, that x minus 4 is not going to divide out. So if that is 0, we have a problem. So we'll have a vertical asymptote when x minus 4 is 0, when x is 4. So 4 can't be used. It doesn't divide out since the top doesn't factor, so my vertical asymptote is x equals 4. Horizontal asymptote, well, that only happens if they have the same degree top and bottom, which they don't, or if the bottom has a degree that's bigger than the top, which it isn't. So no horizontal asymptote. Look at the top. The top has degree 2, the bottom has degree 1. But that is 1 more, right? The top has a degree of 1 more than the bottom. So when that happens, we do have a slant or oblique asymptote. And again, that happens because there is a 1 difference between the degrees. Difference of 1. Top is bigger by 1. And we're going to find that by either using synthetic division or polynomial long division. So let's look at the process of finding the equation of the slant asymptote. I will do polynomial long division first. X minus 4 into 3x squared minus 14x plus 9. 3x squared divided by x is 3x. 3x times x is 3x squared. 3x times negative 4 is negative 12x. And then we have to subtract. And this is where people often have difficulty. 3x squared minus 3x squared is 0. Negative 14x minus negative 12x would be the same thing as negative 14x plus 12x, which would give me negative 2x. And of course, the 9 doesn't subtract out. And I do one more division. Negative 2x divided by x. Negative 2x divided by x is negative 2 minus 2. Minus 2 times x is minus 2x. Minus 2 times minus 4. And negative 2 times negative 4 is 8. And again, we're going to subtract. See what we get? Negative 2x minus negative 2x is 0. 9 minus 8 is 1. So that my remainder here is 1. So this is really plus 1 over x minus 4. But this part gives us the slant asymptote because as x gets large, 1 over a million minus 4 is basically 0. So the equation of my slant asymptote will be y equals 3x minus 2. That's how we get it from long division. But I can also get it from synthetic division. Let me show you that process. If I'm doing synthetic division, I just put a 4 out there, x minus 4. We have 3, negative 14, 9. Bring the 3 down, 4 times 3 is 12. Negative 14 plus 12 is negative 2. 4 times negative 2 is negative 8. 9 minus 8 is 1. 3 comma 2 corresponds to 3x minus 2. And again, your equation there is y equals 3x minus 2 with remainder 1 over x minus 4. So that is our slant asymptote, our oblique asymptote, y equals 3x minus 2. Our vertical asymptote was x equals 4. Now we need to look for intercepts, x and y intercepts. So again, let's look at our original function here. And I tried it. So our function was f of x equals 3x squared minus 14x plus 9 all over x minus 4. If I want to get the y-intercept, all that is plug in 0 for x and see what you get. If I plug in 0 for x, I get 3 times 0 squared minus 14 times 0 plus 9 over 0 minus 4, 0 minus 0 plus 9 over 0 minus 4, negative 9/4. So the y-intercept, x is 0 and y is negative 9/4, which is what? Negative 2 1/4, I believe. To get the x-intercepts, I have to set y equal to 0. Set y equal to 0. But the y is, of course, the f of x. So 0 equals 3x squared minus 14x plus 9 over x minus 4. I set y equal to 0. I set 3x squared minus 14x plus 9 over x minus 4 equal to 0. When does a fraction equal 0? When the top equals 0 and the bottom doesn't. So I need to solve 3x squared minus 14x plus 9 equals 0. So how am I going to do that? This quadratic formula, I believe, is my most efficient strategy for that. So let's do it. What do we have? 3x squared minus 14x plus 9 is 0. Remember, we're using quadratic formula, ax squared plus bx plus c equals 0. A is 3, b is negative 14, and c is 9. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is negative of negative 14, which is positive 14, plus or minus the square root of b squared, negative 14 squared, minus 4 times a times c, 4 times 3 times 9, all over 2a, all over 2 times 3. So we get x is 14 plus or minus the square root of negative 14 times negative 14 is 196 minus 4 times 3 times 9 is 108 all over 6. So from there, what do we get? We get 14 plus or minus 196 minus 108 is 88, plus or minus the square root of 88 over 6. Now, I could certainly simplify that because I can pull out a 4. That's 4 times 22. That's 2 root 22. But all I want are decimal approximations. So my answer is currently now, our x is 14 plus root 88 over 6. I'm going to get a decimal approximation for that. And x is 14 minus root 88 over 6. Again, root 88 is note, that's 4 times 22. So if you want to make this a little prettier, root 88 is 2 root 22, and you could reduce the fraction. Maybe I should do that. Let's go to the next page. X is 14 plus or minus root 88 over 6, which is 14 plus or minus root 4 times root 22. Whoops, can't see any of that. Over 6. So x is 14 plus or minus 2 root 22 over 6, which is 14 over 6 plus or minus 2 root 22 over 6. 14 over 6 divided by 2, 7 over 3, plus or minus 2 over 6 is 1 over 3, 1, root 22 over 3. So I get my two intercepts. I get x is 7/3 minus root 22 over 3, and x is 7/3 plus root 22 over 3. Let's get decimal approximations, then I'll write them in point form. What do we have? 7/3 minus the square root of 22 divided by 3 gives me 0.770 basically, approximately. 0.770, and on the other one we have 7/3 plus root 22 over 3. I get 3.897. So my x-intercepts, that's when the y value is 0, 0.770, comma 0, and 3.897, comma 0. So we would like to see the x-intercept, the y-intercepts, the slant asymptote, the vertical asymptote, and the domain, all by looking at Desmos. So let's go there now. To Desmos. When I am ready to go to Desmos, we're going to graph this. So here it is. We're going to pull it up. It is f of x equals 3x squared minus 14x plus 9. Divided by x minus 4. Okay, so we said that 4 was not in the domain. We said we had a vertical asymptote at x equals 4. And that looks good. But again, I can't see what's happening to the rest. Ah, there we go. So there's the other part of the graph that we're working with. Now, what about my slant asymptote? What did I say that was? My slant asymptote was y equals 3x minus 2. So y equals 3x minus 2. Let's make that a different color. And you can notice that as we move farther and farther away from the origin, this graph gets closer and closer to that slant asymptote. So we feel good about the vertical asymptote. We feel good about the slant asymptote. We feel good about the domain, right? Everything works except for 4. So how about our intercepts? What did we say we had? Well, the y-intercept was 0, negative 9/4. So I'm going to go back to this place. Can I find 0, negative 9/4? Negative 2 1/4, negative 9/4. Feel pretty good about that. Now my x-intercepts were 0.7700 and 3.8970. Just look at the picture. Can you believe that this point intersects at 0.770? Sure does. The other one, 3.8970, let's see if that looks right. 3.8970. So the x-intercepts checked. The y-intercept checked. The slant asymptote checked. The vertical asymptote checked. The domain checked. So we feel good about this.